Hi, in this video, we're going to talk about a linked list that can store data in sorted order. So we know our node class can insert or remove another node after itself, right? So that means if we somehow get our hands on a node in the linked list, then we can insert or remove really kind of anywhere in the linked list. And the example we're going to look at is that if we're given a list of random numbers, we want to insert them into a list that is sorted in the ascending order. And ascending order meaning the smaller one comes before the bigger ones. So let's see how we can do that in a linked list. So the big idea here is to find the right node to insert the data after. So let's assume we have a linked list that is already sorted. So in this case, this is kind of in the middle somewhere in this linked list, we have 66 and 99. And the new number that we want to insert is 88. So we know 88 should go between 66 and 99. So what is the right node that we have to find? So the right node is a node whose next node contains the data that is larger than the number we want to insert. So the right node here is the node that has 66. Its next node is 99. So we know then we have to insert the 88 after 66. Okay, now it's important that we're not looking for the node that contains the data larger than 88 because that node would be 99. But if we just find the node that contains 99, we cannot insert 88 before it, right? So we have to find the node 66 so that we can insert 88 after it. So that's kind of the key here. And what happens once we find the node whose next node is larger than the new data? Well, it's a simple matter of calling insert after, insert the new data after the quote unquote right node. So to find the right node in the list to insert after, we basically have to walk through the entire list and look at each of the nodes in turn, right? That's basically a traversal that we've done previously, like in the string method. So basically, we'll start at the head, and remember the head is not the one that we really care about because it doesn't contain data. So we really start at the head dot next, and then we find the node that whose next node's data is larger than or equal to the data that we're trying to insert in. And once we find it, we can break and we can do an insert after the right node of the data that we wrap in a data node. Now, if we don't find, if the current node is not the right node, then we just advance to the next node. So basically that's the code. It's just a few lines, but we have to make sure that it works for all cases, and all these cases would include there's an insertion at the head, insertion in the end of the linked list, and also insertion in the middle. So we'll step through the code to see that it works in all these cases, hopefully. So the first case is we're going to insert data into an empty list, and so it should be inserted at the head as the first element of the linked list, right? So the number we're inserting is 66, and so we initialize the temp to point to the head, and the first condition is while temp dot next is true. So basically, it's not going to be true because temp dot next is going to be pointing to none. So we'll this will be false, and we'll skip to the temp dot insert after the head or the temp. So insert after this, we create a new node that holds the new data 66 and it's there. So this looks correct. Now it's a linked list with a single element of 66. The next case we're going to look at is that we're going to insert a number that would go to the end of the linked list. And because we know the linked list now has 66, if we just insert a number that is larger than 66, it should go to the end. So we're inserting 99. And again, we start temp at the head and temp.next. That is now pointing to a node. So this is going to be true. And it's going to go inside the loop, and it says, okay, data, is it less than or equal to temp dot next dot data? Well, 66, the data is 99, so 99 is not less than 66, so this is going to be false, and it's going to advance temp to the next node, and it's going to come back out to the condition of the loop, temp.next. Temp.next, well, it's pointing to none, so that's going to be evaluated to false. And we're going to exit the loop and insert the new data, wrap in a new data node after temp. So here is the new list that has 66 and 99. It is sorted, and so we correctly insert the new number. So we're going to look at the final case of inserting a new piece of data somewhere in the middle of the linked list. We know number 88 should go between 66 and 99. So let's start. Once again, we start from the head, temp pointing to the head, and next has something, so it's true. We come in here, is 88 less than temp.next data, which is 66. It's not less than, so we advance the temp pointer to the next one, and then we come back here to check this condition. Okay, is temp.next, is it pointing to something? Yes, it is. We stay in the loop. Now we check, is 88 less than temp.next data, which is 99. Well, 88 is less than 99, so it's true, and we break out of the loop. And now we insert temp is pointing to 66, so we're inserting 88 after 66. So after we're done, we check the list, and good that it is still in the sorted ascending order. And now I would like you to try to do very similar things, but inserting the number 11 and 22 and 100 by drawing the pictures and step through the code and make sure that they work correctly. All right, hopefully you've done that. The next thing that we want to do is that we want to, given a piece of data, we want to be able to remove it if it is in the linked list. So we return true if the data is found and removed. Otherwise, we'll just return false to say, no, we didn't find the data. So if you want to, you can try to write this remove method yourself first. It's going to be fairly similar to the insert method. And here is the way that I would do it. So we are going to start off the same way. We start at the head and we look at temp.next. Have we reached the end yet? And we compare the temp.next data to the data that we're trying to remove. And if it is in the temp.next node, then we remove the node after temp, right? And once we remove it, we're done, so we return true. Otherwise, we advance the temp pointer until the end of the list. And if we exit this loop without finding the data and returning, then the data is not in the list, and in that case, we'll return false. So now let's actually step through one example to make sure that it works. So let's try to remove the number 88. So we start the temp at the head, and we look at temp.next. That's obviously true. So we look at temp.next.data temp.next.data, that is 66, is it equal to 88? No, so it's false, and we advance the temp pointer to the next one. We come back here, temp.next, that is pointing to something, so that is true. We come in here, temp.next.data, that is 88, and that is equal to the number that we're trying to remove. So this is going to be true, and we are going to remove the node after temp. So we're removing a node that contains 88, and we return true. So that's removing data in the middle of the linked list. Now I would like you to try the rest of the cases. So first try to remove 99, and that would be at the end of the linked list. And next remove 66, that's at the beginning of the linked list. And then finally try to remove a number that is not in the linked list, such as 100. And make sure that correctly returns false. So please step through the code for each of these cases and draw the pictures like I did, and make sure that you understand how this few lines of code handle all those cases correctly.